So hello dear students. Today we'll solve question number 54 of GATE 2025 exam. Okay, so there is something I want to tell you. And if you want to see a quick course of GATE on function analysis and want to learn theory very quickly and solve the questions of GATE examination, then you can purchase the membership of 1199 in our channel and go through that course and then come back to see the solution of all these questions. I mean, you will feel easy to solve the questions, okay? Because I had already covered the theory part. So in the course tab of this YouTube channel, you will be able to see that. So let's start. So student, you will see today that how what we were doing yesterday helps us to solve all these questions. So today we'll solve all the questions of grade 2025 of functional analysis, and you have to you are here to catch the mistakes if I make something, okay? So and all other students are requested to watch this video once it's uploaded on a YouTube channel. And one other information is that so there will be a mini crash course of GATE examination. So daily videos will be uploaded. Those will be public and also will be in some exclusive videos will be in membership section. So you can purchase the membership of 199 rupees and access all those videos. So let's start. Okay. So what this question 54 says, see, let Xk be an orthonormal set of vectors in a Hilbert space X with the inner product. So, and let n, this is fixed now, okay? So, and y be the linear span of xk over R for x belongs to x, define or let Sn x is this vector, okay? So, this is the linear combination of xk's whose, coefficient are, see, these. Then which of the following is are true? So this is a multiple selected question. So let's solve this one by one. So option A says that Sn is orthogonal projection of x into onto y. So I want to ask you, student, that how do you know that some vector is orthogonal projection of a given vector on some space? So you have learned the theory already, right? Suppose y is a, and let me tell you, let me ask you first, y is closed subspace or not? Let me know. Y is closed or not? Yes. Aman, did you say
Yes,
so?
y is closed because
Yeah.
it is a finite dimensional.
Yeah, it's
Orthonormal set मतलब linearly independent होगा.
yes.
It is spanned by finite dimension n dimension
Yes,
over
yes.
R.
Answer is that's fine. Okay. Answer is fine. So it's a finite dimensional norm-vector subspace. So it must be closed. Okay. So how do we know that some vector of a Hilbert space x given x is ortho? I mean, given some vector in y, suppose you pick some vector x from here and I give you something from here, say y, then how do you know that y is orthogonal projection of x or not? What is the criteria for that? So that you should remember that I had told in the last class. Yeah, yeah, please.
जो x minus जो element from y जिस element से होगा projection का तो उस जो vector होगा वो perpendicular to each element of y.
Yes, or we can say that y minus x is perpendicular to y. This is the characterization of the orthogonal projection, right? This is the way that we
Yes.
do know that something is orthogonal projection or not. So we will use it here. So let me write the solution A. Snx is equal to summation k goes to 1 to n is orthogonal projection of orthogonal projection of x onto y if and only if Sn x minus, I think A and C will be solved simultaneously. So Sn x minus x, yeah, x minus Sn x. You can write anything, okay? So perpendicular to whole space y. That means that it is perpendicular to each of the spanning vector, right? Or each of the vector of y. So if and
Yes, sir.
only if x minus Sn x is? Because y is spanned by these vectors x1, x2, dot, 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 xn. So if something is perpendicular to each of these vectors, that must be perpendicular to whole of the space, right?
हाँ
So
सर
if and only if xk for each k. And we did this yesterday, right? In the theory class.
ये डायरेक्ट थ्योरी है
Yes, that theory. So, but let's verify here, okay? Because many of the students will see it in the YouTube, okay? So k goes to 1 to n x minus xk into xk. So I'm gonna verify for each k, okay? So this inner product comes out to be, see, by linearity, this will be, first of all, x minus xk minus then summation k goes to 1 to n inner product of x, xk, here xk and xk. See, these, this is a orthonormal set, right? By linearity, this will comes out to be, I will use the orthonormality here. So by linearity, this will comes out to be k goes to 1 to n, and this scalars will come out. These scalars will, okay, out, and we get this, right? But I think I, instead of writing it k, I should write j, right?
यस सर
Hmm. So xj, this will be, so far it's clear, right?
यस
And
सर
this, and now see, x, it is not x,
सर
xk, xj,
on
right?
the इक्वेशन x मान x x k का इनर प्रोडक्ट नहीं होगा x x j का होगा आप तो फर्स्ट टर्म को रिपीट कर रहे हैं ना देखिए आप वहाँ पे x x k लिखा है
हाँ हाँ हाँ, वो भी,
माइनस
yes yes yes, I have to make correct this also, right?
हाँ हाँ हाँ
Thank you. So yeah, so it's clear so far, right?
ओके सर
Let me write here j also, okay? यहाँ पे ऊपर भी लिख देता हूँ मैं. So see, now we get only this from there, right? And this comes out to be 0. Why? Because this only the term for which, I mean, k, whenever we, when k equal to j, we get norm of xj, which is 1. So we get for that summand this one, and other terms are 0, right? Other summands are 0 because whenever k is not equal to j, inner product of xk and xj is 0. That's why we get this. So we get that this vector is orthogonal to each of xj, hence it's orthogonal to y. Okay, so that's why it's the orthogonal projection of x onto y. So option A is true, C. And the option C says that x minus Snx is orthogonal to Snx for all x. Right, this is also true. Yes or no? Gaurav, you tell. C. This is true. 0 or not. So you can see what is Snx. Snx is this. Okay, let me write for you. And you tell me, this is true or not?
हाँ सर ये तो लीनियर कॉम्बिनेशन x के है ना तो स्पैन ऑफ x के में बिलोंग करता है तो
Correct.
स्पैन ऑफ x के तो y है तो y के साथ तो परपेंडिकुलर हो ही रहा है
This vector is orthogonal to each vector of y, and this vector is also in y. Okay, so this is absolutely true. I mean, this is true. Okay, so because Snx is an element of y, so A and C are correct, right? And what about B? X, Snx is orthogonal projection of x into y. No, B is not true, right? Because X, see, Sn X is non-zero for many of the vectors, right? And this is non-zero then, right? When it, if, uh, I mean, we know that there are vectors when X and Sn X are different. Yes or no? There
Yes,
are
sir.
vectors, right? When X and Sn, because X and Sn X are equal if and only if X is in Y, right? Because
Yes,
Snx
sir.
is the closest vector from X. So in Y. So if X is in Y, then Snx will be equal to X. But if X is outside Y, then that is not equal. So it means that that is a non-zero vector. So in that case, the norm of this vector will be non-zero, and hence, but this thing is, you know, hence X minus Snx is not perpendicular to Y per to wiper, which means that this is not orthogonal projection. Okay, not dot dot dot. You can fill it, so it's wrong, right? Any questions? Aman, clear hai?
Oh, yes, sir. Clear.
Okay. So now the fourth one, you tell. Fourth one is true or not?
No, not necessarily true.
Yeah, it's not necessarily true. So we have to give an example. So this is okay. We have to give an example. So give me an example. And you can we can pick L2, right? L2 and the this orthogonal set. So in this case, we fix n equal to just take E1. Okay, take n equal to 1. So then in that case, according to option D, norm of x square must be 1, right? In this case, this quantity comes out to be 1, right? So here,
Sir.
no, no, it will depend on, I mean, not 1, but this will be x into E1 mod square. That will comes out to be x1. So this will be mod x1 square. Not necessarily true, right? Or not necessary. It's not necessary because if you can pick x e1 plus e2, then that's mod is that's not square is not this, है ना? मतलब if you आप ये वेक्टर ले लो, मेरे कहने का मतलब है 1+1, उसमें ट्राई करके देखो. So we'll not pick this because its norm is 111 root 3. So but other side says that it will be equal to 1, which is upside. So yeah, any questions?